Oh, welcome to Rediscovery, where the wonders of space and science ignite. The Sun, our very own star. This colossal ball of plasma illuminates our world. It provides the energy for life, but the Sun is not a static object. It is a dynamic and powerful entity engaged in a constant dance of spin and energy. The Sun's rotation is not just a simple turning motion, it's a complex phenomenon that influences everything in our solar system. At the Sun's equator, the speed of rotation is astonishing. Imagine traveling at over 7,000 kilometers per hour. That's the Sun's equatorial spin speed. But here's where it gets interesting. The Sun doesn't rotate at the same speed everywhere. Unlike a solid sphere, the Sun is made of plasma. This allows for different parts to rotate at different speeds. This difference in rotation speed is known as differential rotation. Differential rotation is a key ingredient in the Sun's ability to generate its powerful magnetic field. Imagine a cosmic dynamo churning deep within the Sun's core. That's what differential rotation creates. This dynamo effect is essential for the creation of sunspots, solar flares, and other solar events. The Sun's rotation is a fundamental aspect of its nature. It is a dance that has been going on for billions of years, and it is a dance that will continue for billions more, shaping the destiny of our solar system. The Sun's differential rotation is a fascinating phenomenon. Imagine a celestial waltz where the dancers don't all move in unison. That's the Sun's rotation in a nutshell. The equator spins faster, completing a rotation in about 25 Earth days. As you move towards the poles, the rotation slows down. At the poles, a rotation takes roughly 36 Earth days. This difference in rotation speed is not just a curious fact, it has profound implications for the Sun's behavior. The varying speeds create shear within the Sun's plasma. This shear in turn plays a crucial role in generating the Sun's magnetic field. Think of it like stretching a rubber band. The more you stretch and twist it, the more potential energy builds up. The Sun's differential rotation is a key driver of solar activity. The stretching and twisting of the magnetic field lines due to differential rotation lead to the formation of sunspots, solar flares, and coronal mass ejections. These events can have significant impacts on Earth, disrupting satellites and power grids. Understanding differential rotation is crucial for unraveling the mysteries of the Sun. It is a complex process that scientists are still studying today, but one thing is clear. Differential rotation is a fundamental aspect of the Sun's dynamic nature. The Sun's magnetic field is a force to be reckoned with. It extends far beyond the Sun itself, encompassing all the planets in our solar system. This vast magnetic bubble is known as the heliosphere, and at the heart of it all is the Sun's rotation, constantly generating and shaping this powerful force. Imagine the Sun's magnetic field as a series of invisible lines extending out into space. These lines are not static, they are constantly moving and changing, influenced by the Sun's rotation. The differential rotation we discussed earlier plays a crucial role here. As different parts of the Sun rotate at different speeds, the magnetic field lines get stretched and twisted. This twisting and stretching create pockets of intense magnetic energy. Think of them as magnetic knots. These knots are the birthplaces of sunspots, solar flares, and coronal mass ejections. When these knots snap and realign, they release tremendous amounts of energy, sending bursts of radiation and charged particles out into space. The Sun's magnetic field is a dynamic and ever-changing entity. It is a force that shapes our solar system, influencing everything from the auroras on Earth to the behavior of the solar wind. The Sun's magnetic field is anything but calm and quiet. It is a realm of intense activity where magnetic fields twist, tangle, and erupt in spectacular displays of energy. Sunspots, solar flares, and coronal mass ejections are all manifestations of the Sun's magnetic dynamism. Sunspots, those dark blemishes on the Sun's surface, are regions of intense magnetic activity. They appear darker because they are cooler than the surrounding plasma, but don't let their appearance fool you. Sunspots are often the precursors to more dramatic events. Solar flares are sudden, intense bursts of energy released from the Sun's surface. Imagine 1 billion atomic bombs exploding simultaneously. That's the kind of energy we're talking about. Solar flares are often associated with sunspots and are caused by the sudden release of magnetic energy. Coronal mass ejections, or CMEs, are the most powerful eruptions on the Sun. These events launch billions of tons of plasma into space at incredible speeds. CMEs can disrupt satellites, power grids, and pose a radiation hazard to astronauts. Think of them as giant solar storms capable of wreaking havoc on our technological infrastructure. These solar fireworks are a reminder of the sun's immense power. They are also a testament to the importance of understanding space weather and its potential impact on our planet. Earth's starry dance partner, solar impacts on our planet. The sun's influence on Earth is undeniable. It is the source of our light and warmth, driving our climate and weather. But the sun's influence extends far beyond a pleasant day at the beach. Our star is a powerful force, nurturing and disrupting life on Earth. The auroras are visible manifestations of the sun's influence. These displays are caused by charged particles from the sun. Imagine a celestial ballet painting the sky with vibrant hues. But the sun's influence is not always benign. Solar flares can disrupt our technology, causing power outages and communication blackouts. Understanding space weather is crucial in our tech-dependent world. The sun's influence on Earth's climate is actively researched. Even small variations in solar energy can impact our climate. Understanding these variations is crucial for predicting future climate change. Space. Weather Watch navigating the solar wind. The space between the sun and Earth is not empty. It is filled with a constant stream of charged particles known as the solar wind. This wind, constantly blowing from the sun, carries with it the sun's magnetic field, extending its influence throughout the solar system. Think of it as the sun's breath, carrying its energy and influence to the far reaches of our cosmic neighborhood. The solar wind is not always constant. It ebbs and flows, influenced by the sun's activity. During periods of high solar activity, such as solar flares and CMEs, the solar wind can become much stronger, creating what is known as a solar storm. These storms can have significant impacts on Earth, disrupting satellites, power grids, and communication systems. Imagine a hurricane in space, capable of knocking out power grids, disrupting communication systems, and even posing a radiation hazard to astronauts. That's the potential power of a solar storm. Fortunately, scientists are constantly monitoring the sun's activity, providing early warnings of potential solar storms. Just as we track hurricanes and other severe weather events on Earth, space weather forecasting is becoming increasingly important in our technology-dependent world. Stellar comparisons: the sun's spin among the stars. Our sun, while unique to us, is just one of billions of stars in the Milky Way galaxy. And like every star, it has its own story to tell, a story written in its spin, its magnetic field, and its interactions with the surrounding space. Compared to other stars, our sun is relatively calm and stable. It is what astronomers call a main sequence star, happily fusing hydrogen into helium in its core and shining brightly for billions of years. But not all stars are so well behaved. Some stars, particularly younger, more massive stars, rotate much faster than our sun. These rapid rotators generate incredibly powerful magnetic fields, leading to intense stellar winds and frequent outbursts of energy. Imagine a star spinning so fast that it's nearly ripped apart by its own rotation. Other stars, particularly older stars that have reached the end of their lives, rotate much more slowly than our sun. These stars have exhausted their nuclear fuel and are in the process of shedding their outer layers, forming beautiful planetary nebulae. By studying the spin and magnetic activity of other stars, astronomers can gain a better understanding of the processes that govern the lives of stars, including our own. The sun's cosmic ballet, a force to behold. The sun's spin is more than just a simple rotation. It is a fundamental force that shapes our solar system and influences life on Earth. From the aurora borealis to the solar wind, the sun's rotation is a constant reminder of our star's immense power and our interconnectedness with the cosmos. As we continue to explore the universe, we are discovering that rotation is a fundamental property of celestial objects, from planets to stars to galaxies. Understanding the dynamics of these spinning objects is crucial for unraveling the mysteries of the cosmos. The sun's spin is a dance that has been going on for billions of years, and it is a dance that will continue for billions more. It is a dance that connects us to the vastness of space and reminds us of the incredible forces at play in the universe. So the next time you feel the sun's warmth on your skin, Take a moment to appreciate the incredible force behind it. The sun's spin is a testament to the beauty and power of the universe and a reminder that we are all part of something much greater than ourselves. Thanks for watching.